Good morning. Today's video, let verify the characteristics of series circuit. So we are consider here the DC series circuit. So first we have to draw the simple passive DC circuit. For that I collect the one cell and resistor from the component library. First I place the cell in the schematic area, then I will select 3 resistors connected in series. So I will place like this. Better we have to place all the component in the convenient position. Here we are going to check the characteristics of the series circuit. We know that in the series circuit current is same, the voltage will differ. The meaning, the current flowing in this circuit is common for all the elements. Here I am selecting R1, R2 and R3, 3 elements. So the current flowing through these 3 elements will be same. The voltage across each element will be differ. So what will be the total resistance of the entire circuit is simply the addition of R1 plus R2 plus R3. Likewise, the total voltage which is given to this circuit will be the drop across each resistor. That means the voltage across R1 plus the voltage across R2 plus the voltage across R3 will be the total voltage. This we are going to check now. So first we have to change the value of entire element. First I have to change the battery value into 28 volt. Why I have to make 28 volt I will explain later. In order to calculate easy values I fix 28 volt. Okay. There is no any other reason. So R1 I have to make only 2 ohm. Then only easily we can understand the voltage and current value. That's why I have to make simple values. Any value you can place. So easily I have to teach you. I select the values accordingly. So I select R1 is 2 ohm, R2 is 4 ohm, R3 is 8 ohm. What will be the total resistance? R1 plus R2 plus R3 is nothing but 14 ohm. Say what is the total current? Total current equal to V total voltage divided by total resistance. Total voltage is 28 volt. Total resistance is 14 ohm. 28 divided by 14 equal total current will be 2 amps. 2 14s are 28. That's why I have to select the values accordingly. So any value you can select. For any values the circuit response will be the same, but in order to easily teach you I select the values accordingly. So now everything is over. Now we have to select one ground. Then later we have to select the, I consider here the circuit is DC circuit, so that I have to take the voltmeters. 4 voltmeters I need. 4 voltmeter. 1 voltmeter I have to place across R1. The second one is I placed across R2. The third one is I placed across R3. The fourth one I want to measure the total voltage. That's why I have to place the 4th voltmeter across the battery. So 1 ammeter is enough. 1 DC ammeter is enough. I can place the DC ammeter here. Why? Because the current will flow through this series circuit will be same. 1 ammeter is more than enough to measure the current, but I have to prove the current flowing entire element will be the same. That's why I connect one more ammeter at the end. Okay, this is not required. Why I have to do so? In order to understand the current flowing prove the series circuit will be the same. I want to prove that. So that I take a 2 ammeter, one I will connect in the input entering current, one I connect at the end, that is leaving end. I have to show that both current will be same. So now we have to connect the all connection accordingly. First I have to connect series. So ammeter and all other components connected in the series connection. The previous video I explained how we have to make the series connection. One starting end is connected to the other element ending end. So if you are doing so, that is the series connection. Parallel connection means starting end connected with the starting end, ending end connected with the ending end. So I finish the series connection. You must know that ammeter should connected in the series. So I have to make it. Voltmeter connected in parallel. The first voltmeter, what the connection I have finished is the total voltage. That voltmeter should connect across the battery, so that voltmeter plus connected to the cell plus, voltmeter minus connected to the cell minus. Let us consider this is the V1. V1 is connected across R1, so plus connected to the R1 plus, minus connected to the R1 minus. This, let us consider this is the voltmeter 2, voltmeter 2 plus connected to the R2 plus, voltmeter 2 minus connected to the R2 minus. This is voltmeter R3 should connect plus connect with the R3 plus, minus connect with the R3 minus. So these voltmeters measure the voltage across each element. That means this voltmeter measure the voltage across R1, this voltmeter measure the voltage across R2, this voltmeter measure the voltage across R3. If we add these three voltmeter values, we can get the total voltage. Okay, this is total voltage. We can add this voltage plus this voltage plus this voltage, we can get the total voltage. So total voltage Vt equal to V1 plus V2 plus V3 in series circuit. Similarly, the current flowing this circuit is same. So whatever the current enter into the circuit, the same current will leave at the circuit. So the both ammeter current will be the same. If you connect the ammeter here, that will be the same current. If you connect the ammeter here, the current will be the same. Okay, this is the concept. Now we have to check the response. So everything is over. Already we changed the value of the resistor and the cell, everything. Now what will be the current? 28 divided by 14. Total resistance is 14 ohm. Total voltage is 28. So I equal to V by R. Total voltage divided by total resistance. 28 divided by 14. I equal to 2 amps. Just we have to check now. So just you can pause the simulation. Now you can see the ammeter is 2 amps plus 2 amps. The same current will be at the leaving ammeter. I connect one ammeter at the end of the connection, starting of the connection. Both ammeter shows the same reading, 2 amps, 2 amps. The total voltage will be the 28. V1 is 4 volt, V2 is 8 volt, V3 is 16 volt. You can add all these 16 plus 4 is 20, 20 plus 8 is 28. So Vt equal to V1 plus V2 plus V3. Okay. So this is a simple DC series circuit. Here we can verify the characteristics of the series circuit. So in the series circuit, current will be the same. The voltage across each element is the total voltage. Sum of the voltage of each element. The sum of the voltage of each element will be equal to the total voltage. Okay. So subscribe the channel, like and share the